This is Unit 1, Lesson 8, and this lesson covers pages 19 through 23 in your notes. This is a pretty long lesson. Hopefully it won't take me more than 30 minutes, but bear with me. I'll try to get through it as quickly as I can but still be as thorough as I can. So absolute value we talked about on Monday. We did absolute value. We looked at absolute value graphs. We looked at absolute value equations and inequalities, and we did some classwork on that today. Today we are going to look at the absolute value graphs more in detail, more in depth, and look at the key features, key meaning important features of the graphs. We've already looked at a few, but we're going to add some more. So just as a review, absolute value is the distance from zero. And any number, the absolute value of any number is going to be a positive number. So the absolute value of negative 4 is 4 units from 0. So the absolute value of negative 4 is going to be positive 4. If you remember talking about driving backwards and how that won't take miles off the car, that's not a negative mileage. It still adds up the miles. If I drive from here to Charlotte and then back, I didn't go 0 miles. So let's look at the parent function one more time. Parent function is y equals the absolute value of x. And of course, we don't really need to do these tables. You're going to have these tables on your activity tomorrow, but you really won't need them. You'll be able to graph these without it. But if we just did a few random numbers, let's do those, and then we took the absolute value of those numbers, it would be 3, 1, 0, and then this one's still 1. So at negative 1 you go up 1, and at positive 1 you go up 1. Parent function, so that's the most basic parent function. I don't want you to worry about this part over here. We're going to look at that later. Parent function starts at 0, 0, has a slope of 1 on the positive side. So it looks like that. We'll put our arrows on the end of it. So that's the basic parent function of an absolute value function. Moving on, let's try a different one. Let's try f of x equals negative absolute value of x minus 2. Again, we could do this xy table, but we don't really need to. If we did, we might put in, say, a negative 1. This would be the opposite, and then we would plug in a negative 1 here for x. So that would be the opposite of the absolute value of negative 3, and that would equal negative 3. I had a positive in there at first. So you could go through this and figure out these values, or we can do it like this. We can say, okay, we know this opens down. A equals negative 1. The vertex is 2, 0, because we take the opposite of this number, and then whatever's out here, there's nothing out there, so it's 0. Vertex is 2, 0, so that's right here. It opens down, and the slope is negative 1. So I have enough points here that I can, and I don't know why this graph is like off for some reason. Maybe there was a different original graph or something, but it's going to look something like that. So just, that's how we graphed them yesterday, and that's the easiest way rather than using this XY table. So all of these XY tables that you have on your activity tomorrow, you can mark them out. You don't need them. Okay, so the first key features we're going to look at are vertex, axis of symmetry, domain, range, and then whether it has a maximum or minimum. We've looked at some of these already, so it should be pretty easy. Vertex is going to be easy because we've done that one before. Vertex is set this thing in here equal to 0. Well, x equals 0, so the vertex is 0, and then this number right here goes exactly like it looks, negative 3. So the vertex is at 0, negative 3. And we can see where it is. Here's 0, 0. So it's at 0, negative 3 if we're looking at the graph. If we're looking at the equation, we do it the way we just did. Axis of symmetry, it's always this number. The axis of symmetry is asking you, where does it cut in half? Just like with your parabola, where does it cut in half, and what point on the x-axis are we looking at? We're looking at x equals 0. So the axis of symmetry is x equals 0. The domain is all the x values that it could be. All the x values it could be, well, it doesn't stop anywhere. It goes in a different, it goes down here and then back up here. That's not really important. It's if I laid this thing out flat, does it go forever left and forever right? It does. So the absolute value, or excuse me, the domain or an absolute value function is always the same thing. It's always negative infinity to positive infinity, or all real numbers. If you put all real numbers, I would count that right as well. Range, we look at where we are on the y-axis. Let me get a different color. Where are we on the y-axis? Where does it start at the bottom and where does it stop at the top? It starts down here at -3. It's included. -3 is included. And then where does it stop? It goes to infinity, going in an upward direction. So that's our range. Maximum or minimum, just look, does it have a bottom or a top? Does it stop at the bottom or does it stop at the top? It stops at the bottom. That's a minimum. That's the bottom of the hill. So it has a minimum, and the minimum is at, it always matches that number right there, -3. Just for your information, you might also see the range sometime as y is greater than or equal to -3, something like that. So you might see a range that looks like that, as well as this interval notation. All right, moving on. The next one is number 2. Vertex is at -4, 3. And we can see that. Here's 0, 0. Here's the origin right here. So pay attention to where the origin is on these graphs. So -4 and 3. Axis of symmetry is always this number right here. So it's x equals -4. Domain, let's draw our arrows. Drives me crazy not to see them. The domain, all real numbers, always all real numbers for absolute value functions. Range, where does it cross the y-axis? Crosses the y-axis at 3. So the range starts at 3 and goes up to positive infinity. It has a minimum, and the minimum always matches that number. The minimum is 3. Okay, so this one I would encourage you to pause your video, try it, and then come back and see if you got everything right. Okay, so if you paused your video and came back, you should have all of these filled in. Your vertex is 5, 0. Axis of symmetry matches the x value, x equals 5. Domain is always the same, all real numbers. The range, it stopped at 0 on the x-axis. It has a maximum because that's the top of that hill, and the maximum is at 0. So I'm going to leave number 4. I want you to try that one, and you can check it with me in class. Okay, so let me get this pen working better. So x-intercepts and y-intercepts, if you remember, we said x-intercepts are the same as roots or zeros. They're called all those things, and the words are interchangeable. To find the x-intercepts, what we would do is, if we just have the equation and not the graph. Of course, if you want to go graph it, you can go graph it and find the x-intercepts. But if all you have is the equation and you don't have Desmos, here's how you would find the x-intercept. You let y equal 0. So if y equals 0, that means 0 equals 2 absolute value of x minus 3. Let's turn that around. Equals 0. So this is an absolute value equation. So what I need to do is get the absolute value isolated and then split it up. So let's see, let's add 3 to both sides. So that means 2 absolute value of x equals 3. Divide by 2. So that would give me absolute value of x equals 3/2. And then I would take it out of the absolute value bars, set it up just like I would an absolute value equation. X equals positive 3/2 and x equals negative 3/2. So if I wanted to check my answer, I could go over to Desmos. I've got that one actually graphed right here, and I see that it's negative 1/2 and positive 1/2, which equals negative 3/2 and positive 3/2. So I know I did that right. Y-intercepts let x equals 0. So we'd set this up. Y equals 2 times the absolute value of 0 minus 3. And then just do the math. Y equals 2 times 0 is 0 minus 3 is negative 3. Well, I still have it graphed over here. Y-intercept is at negative 3. So that was correct. So we'll do one. Let me see. Yeah, we'll do a couple more of these. So let's see. I'm going to go ahead and switch this around to absolute value of x plus 4 plus 3 equals 0. Get this by itself. Remember how we did that yesterday on the absolute value equations. So absolute value of x plus 4 equals negative 3. Well, we can actually stop there with this one because we can't have an absolute value that equals a negative number. So this can't happen. So that means there are no real roots. There could be imaginary roots. But there are no real roots. So I'm going to go over here and make that one visible. It's right here, and you can see that there's no x-intercept here. It doesn't cross the x-axis. So let me go back over and do the y-intercept. So let's see. Y equals absolute value of 0 plus 4 plus 3. So the absolute value of this is 4 plus 3, y equals 7. Let's see if that's what we've got here. Yep, y is 0, 7, the y-intercept. Okay, we'll do one more. Negative absolute value of x minus 5 equals 0. Set this equal to 0. When we divide by negative 1, we still have absolute value of x minus 5 equals 0. So set this up. We can't set up a positive and negative because there's no positive and negative. So I get x equals 5. Let's see if there's one. What's this one? Yeah, there's one x. There's one root right there at 5. So we did that right. And then the last one, I'm not going to do the one at the bottom. You can try it if you want to, or you can go graph it and see what they are. So let's see this one. Y equals negative absolute value of 0 minus 5. The absolute value of 0 minus 5 is 5. And the opposite of that is negative 5. We'll go over and check that. Yep, right there. Okay, next page. This is called, and this somehow this ended up at the bottom of your page 20, but this is called intervals of increase and decrease. So I'll just write that up here. So I want you to think about a roller coaster going uphill and downhill. Put my arrows here. Roller coaster, uphill and downhill. If a roller coaster is going uphill, it is increasing in altitude. So we'll say that is an increase. And then downhill is a decrease. Also, what I want you to think about here is I want you to trace, in other words, run your pencil across here from left to right. So always go left to right to look at this key feature. So I don't need to know like anything but the axis of symmetry. So all I need to know right here is where is the axis of symmetry on this thing? On the x-axis, and this one is at x equals 0. Okay, so this is x equals 0. So the vertex is at 0, negative 3, but we're only going to use the x value in this key feature. So what I want to do is trace from left to right, and as I trace from left to right, I want to think to myself, is this graph increasing or decreasing? So as I go from left to right, it's going downhill, which means this is decreasing on the left side. And then on the right, as I go back uphill, this side is the interval of increase. So I want to look at this side and determine what is that interval. Okay, so, and I'm looking at, again, I'm looking at x values. So the interval, as I move from the left to the right, it's coming from negative infinity, kind of like we do domain and range. It's kind of like domain, but we're cutting it in two pieces, okay? So the domain, or the interval of decrease on this side would be from negative infinity to 0, because this is 0. So it's always going to be that number right there. So the decreasing, sorry, this is the decreasing side, so we're down here. Decreasing would be negative infinity to 0. And in this case, I do use parentheses, because at 0, it's neither increasing nor decreasing, so I don't include that number. So it decreases until it gets to 0, and then it stops, and then starts increasing. So I don't include the 0. Over here, it's increasing. It's increasing from left to right, from 0 to positive infinity. 0 to positive infinity. And that's it. If it was pointing downward, it would be the opposite, but just trace left to right, see if it's decreasing or increasing, and go from there. Let's look at another one. So this one is pointing downward, so let's figure out which side is increasing and which side is decreasing. And so on the left, if I'm going from left to right, on this side it is increasing. So I'm just going to put a little note there that that's increasing. So this side is decreasing or going downhill. So the roller coaster started down here at negative infinity, and then it stopped at 5. So that's my number. That's my magic number right there. And then it started going towards positive infinity. Okay, and we're not looking at the downward, the fact that it's going down. We're looking at the fact that it's going to the right. That's the interval. It's from here to here on the x-axis. Actually, it's not to here, it's all the way to infinity, but you get what I'm saying. Okay, so going from left to right, on the increasing side, which is this one here, it goes from negative infinity to 5. We always use this number in both of them. And then the decreasing side, it goes from 5 to infinity. So it's always that same number in both intervals. Okay, let's look at number 7. I want you to pause the video and you try this one. So this is what you should have gotten. On the left side, it was decreasing, and it was going from negative infinity to negative 4. This is negative 4 on the x-axis. Here's the x-axis down here. And then on the right side, it was increasing, and it went from negative 4 to positive infinity. All right, last one in this section. Increasing is on this side. Decreasing is on this side. On the x-axis, it's at 0. Okay, so increasing is negative infinity to 0. And then decreasing is 0 to positive infinity. Okay, we're on page 22. So this is another interval, and we're still using x values here. We are looking at the intervals where y or f of x, y and f of x, same thing, is positive or negative. Now, I want you to understand that, first of all, I've graphed this on Desmos, and I've put the screenshot here. So I'm not going to be sketching this over here, but you can sketch this on your paper. So let's think about what this would mean. It says intervals where y is positive and negative. So if the y's are positive and negative, let me highlight this. So let's do positive in green. Think about the y-axis. Where are the y values positive? Well, they're positive up here in this area, right? So above the x-axis is where the y values are all positive. And then where are the y values negative? Well, they're all negative down here below the x-axis. So what we're looking for is we're asking ourselves what part of this graph is above the x-axis and what part of it is below the x-axis. Well, in this case, the whole thing is below the x-axis. So what I would say is any part of the graph above the x-axis. So positive is where, oh, my original one says f of x is greater than 0, but this one says positive. So you might see what's the interval where f of x is greater than 0? Well, that's where it's positive, and that's this green section up here. Well, if I'm looking at the x-axis right here, none of this graph is above it. So my answer would be does not exist. And I'm gonna, can't stand the way this pen does. So my answer under the positive would be does not exist. Now, where it's negative, well, the whole thing is below the x-axis. So where it's negative is all of it, which means that I would just use the all real numbers. And you might see, again, you might see f of x is less than 0, so that's negative. And I would either say all real numbers or use my interval. So that one was pretty easy because the whole thing was under it. So the whole thing was negative. Let's look at another one. The next one looks like this. And again, I've done my screenshot here. You can sketch this on your paper. You can pause and sketch it, but I've already got it here. So let's look at the x. Let me define the x-axis again. It's right here. So we're trying to figure out what part of this graph is above it and what part is below it. So if I were to highlight the positive, I'm going to highlight the positive parts in green. So here's part of it, and here's another part. And something that we know about when there's two intervals and they're on either side of a number line, if I just think of the x-axis as just a number line, which it is a number line, and I look at like what parts are to the left here and what parts are to the right here, you remember I'm going to use that U symbol. It's going to be two different intervals and so on. Now, if I look at the part that's negative, excuse me, that was the part that was positive. If I look at the part that was negative, I wonder if I can do a red highlighter. Yeah, I'll do that. So here's the part that's negative down here. So if I do the negative, well, that interval goes from here to here. And I don't have to say, oh, it goes down here and then back up here. I'm only thinking about the x-axis. So I only need these numbers that are on the x-axis. So I need this -14 and I need this 2. Those are the numbers I'm going to use. All right, so let's think about this. Positive. Actually, let's do negative first. Let's do negative. It's easier. So the negative part of this graph goes from -14 to +2. That's all you need to do. The negative part is going to be -14 to 2. So the reason we don't do brackets here is because at 14 or at -14 and at 2, it's neither positive nor negative. It's on the x-axis. So we use parentheses here. The intervals where it's positive starts, if I go from left to right, starts at -infinity. I tried to grab green there. -infinity to -14. So that's one of them. And then it also goes from 2 to +infinity. So I would use my U symbol, 2 to infinity. So I can squeeze that in there. So I realized as I was looking back at this that I didn't explain why the vertex is at -6, -4 instead of -3. We've mainly been looking at absolute value functions that have just an x right here. This is called the b value. There's an a right here, and then this is a b value, and we're going to talk more about this during class. But remember that what you do is you set all of this up equal to 0. So 1/2 x plus 3 equals 0. 1/2 x equals -3 multiplied times 2, and x equals -6. So if you set that up equal to 0, that gives you your x value for your vertex, and that's actually your left or right movement is the -6. So you don't just, if it's got something in the b place right here, you don't just look at this number and say, oh, it moved to the left 3. It didn't. It moved to the left 6 because of this b right here. So set all that up equal to 0 and then get x, and that is a left movement 6 places. So if you see the positive part or the negative part is separated, it's going to be two different intervals joined by that or symbol. And then if it just keeps going continuously, then it's just going to be the two numbers that it's between. All right, let's look at another one. Okay, so here we have number 11. Let me see what number 12 looks like. Okay. I want you to pause the video and try number 11. So this is what you should have gotten. The positive interval was from 0 to 4. The negative was from negative infinity to 0 and or 4 to positive infinity. And what I did was I drew or I highlighted the section of the actual graph. But then what I want you to understand is that you're really just looking at the x-axis. So you're looking at this for one interval and this for another interval, the negative, if that helps you at all. You're looking at just the x-axis really. And then the green, you're looking at this interval right here. So it's going to cover the whole x-axis somehow, but part of it is just between these two numbers, and then part of it is going that way and that way, if you remember when we did the absolute value inequalities. The last one is fairly easy. The entire graph is above the x-axis, which is right here. So positive is going to be all real numbers. Negative is going to be does not exist, because none of it's below the x-axis. Okay, last page, page 23. This is at the top. This is in behavior. In behavior means on either side of the graph, what is it doing? What's approaching what? And what we look at is we look at the left side, we look at the right side. Let's draw our arrows up here. This does have arrows. So what I do is I kind of just cut it in half and I look at each side separately. So let's cut this in half here. And let's look at this side. So on the left, let's see, what color do I want to do? I'll do green for left. Okay, so on the left side, here's what I do. I go from this axis of symmetry, or the vertex. Let's go from the vertex. And as we go this way, we look at which direction is the graph going. So the first thing I want to look at is the up or down direction. It's going in an upward direction. And then I also want to look at the left or right. So it's going to the left. Okay, so this is my y values. Up and down is y. Left and right is x, and this is my x values. My y values, if you think about it, we can just make a little note over here. An upward direction is a positive direction. It's going toward positive infinity if it's going in an upward direction. A downward direction is going toward negative infinity. As far as the x values are concerned, going to the right is positive infinity, and going to the left is negative infinity. So if we separate all those so we can just keep up with that. So positive, the y is going in a positive direction. The y is going towards positive infinity. The x's are going toward the left, so that's negative infinity. So here's how we state this. Y, you remember, is f of x also. We can state it in a couple different ways. We can say, okay, on the left side of this graph, y is approaching. That's what that arrow right there means, and you should have seen that before, but I'm not sure if you have. Y approaches positive infinity, and you can put a positive there or just an infinity, as x approaches negative infinity. So as x goes to the left, or as y goes up, x goes to the left. So as y goes up, x goes to the left. That's what that says. All right, let's look at the other side, because it's got two different sides that are separated by this axis of symmetry. So on the right side, my up or down direction is still up. My left and right direction is going to the right. Up is positive, right is also positive. So on the right side of this graph, and I know that gets a little bit confusing talking about the left side and right side, but y is approaching positive infinity. In other words, y is going up as x is going to the right, as x is approaching positive infinity also. So that's in behavior. Just look at each side and look at whether it's going up, down, left, or right, and write it like this with these arrows. This means approaches. Okay, let's do another one. Let's look at this one. Let's separate that. Here's our axis of symmetry. So let's look at the left side of the graph. And sometimes it'll ask you the right side, and sometimes it'll switch the x's and y's. It's can get a little bit confusing. So let's look at the left side. On the left side, it's going down, so downward direction, and it's also going to the left. Both of those are negatives. So this is negative infinity, this is negative infinity. So on the left side, I would say y approaches negative infinity. In other words, y is going down as x is going to the left, which is also negative infinity. On the right side of the graph, so on this side of the graph, it's going downward also, and those always match on absolute value. It's going down and to the right. So negative infinity and positive infinity. Y approaches negative infinity as x approaches positive infinity. So I want you to try the last two on this page, and I'm going to just show you what tomorrow's activity is going to look like. You'll see an equation, you'll see a graph here, and then you'll see all these key features. So I'm just going to go through them really quickly, hopefully in a couple minutes, and show you what you're going to be doing tomorrow. So let's look at this equation first. The equation is absolute value of x minus 3. So we know that our vertex, and we put vertex is over here. Vertex is at 0, negative 3, okay? And then we can mark that 0, negative 3. The slope is 1. It opens up. The slope is 1, and it opens up. So we go ahead and sketch it as well. That's going to end up yellow. That's close enough. Something like that. Okay. The line of symmetry, it just always matches the x value. And I don't do these all in order. I don't start here with domain. Line of symmetry is x equals 0. It has a minimum value, and the minimum value is 3. I'm sorry, negative 3. It doesn't have a maximum value. So what I want you to do is there is draw a line or put none or NA or something. The Xintercepts, it looks like they are at negative 3 and positive 3. Don't put this in parentheses because that would be an ordered pair. Just list them like this. Or you can do this. The Y-intercept is at the vertex negative 3. The domain, all real numbers. The range is from negative 3 to infinity. The interval where x is positive. So that is the part where it's above the x-axis. Where I'm sorry, not x, f of x is positive. So above the x-axis, it goes from negative infinity to negative 3. And then my U symbol. And then it starts back at positive 3 and goes to positive infinity. Where it's negative is down here underneath. And that goes from negative 3. I'm going to write that there, and that's positive 3. I hope I graphed it right. I think that's right. So where it's negative is negative 3 to positive 3. And I know this is fast. We're going to go back over this tomorrow. Interval where it's increasing. Let me change colors here. Okay, so on the left side, as I trace from left to right, on the left side, it's decreasing. And on the right side, it's increasing. So let's go down here to decreasing first. Decreasing, it's going from negative infinity to, what is that? That's 0 on the x-axis, to 0. Where it's increasing, it's going from 0 to positive infinity. All right, in behavior right and in behavior left. I always like to do the left side first. So in behavior, it's going up and to the left. That is positive infinity and negative infinity. So the way I would say that, on the left side, I would say y approaches positive infinity as x approaches negative infinity. Okay, and then on the right side, it's going up and to the right. That's positive and positive. Y approaches positive infinity as x approaches positive infinity. What do I have left? I think I did them all. Okay, so that's what it's going to look like tomorrow. You'll be doing like 6 of these, I think, tomorrow during class.